Now let's look at the 32nd question, which says integral of 1 by 1 plus cot x times dx. So in this context, what we will do is, we will take cot x and write it as cos x divided by sin x. So once this is done, it becomes integral of 1 divided by 1 plus cos x divided by sin x times dx, right? So you take the LCM, then this becomes integral of sin x divided by sin x plus cos x times dx. Now having said this, if you observe, we cannot substitute any of them as t and then proceed, like unlike the other problems. So what we need to do here is multiply here with 2 and divide it with 2, so that you will have something like this. Observe, you will have half of 2 sin x can be written as sin x plus sin x, okay. So what I am going to do is, to replicate the denominator, I am going to add a cos x and subtract a cos x, right. The whole divided by sin x plus cos x, right. So integral of this value times dx. Now what is going to happen is, this sin x plus cos x, write it as one term, and this sin x minus cos x, write it as another term. So having that being done, we get half of integral of sin x plus cos x, the whole divided by sin x plus cos x times dx, plus integral of sin x minus cos x divided by sin x plus cos x times dx. So sin x plus cos x and sin x plus cos x will get cancelled. So you are left out with 1 times dx. So the answer will be half of 1 time dx is going to be x, plus you have integral of sin x minus cos x, the whole divided by sin x plus cos x dx. Now if you observe, right, if I take sin x plus cos x as t, sin x minus cos x will become minus dt, right. So what we can do is, take sin x plus cos x as t, that is the denominator as t, so that when we have this thing, half of x plus, let me rewrite it, integral of sin x minus cos x, the whole divided by sin x plus cos x times dx. Sin x plus cos x as t. So once we do this, we will have cos x minus sin x times dx is equal to dt, right. Now sin x minus cos x times dx is the numerator. So we will have half of x plus integral of dt, the whole divided by, see, cos x minus sin x times dx. Actually, sorry, here it is cos x minus sin x times dx, which implies, if I take the minus sign outside, we will have sin x minus cos x times dx is equal to dt. Push the minus sign to the other side, so that sin x minus cos x times dx becomes minus dt. So here it is going to be minus dt divided by sin x plus cos x is t. So we will have half of x minus, the integral of 1 by t is going to be log t, log of mod t, and you have a c outside. So the final answer would be half of x minus log of mod sin x plus cos x, it is sin x plus cos x plus c. So this would be the final answer. Clear?